Okay, so that takes us to this section on assessments of HVAC systems. The design program requires that our engineer of record gather and analyze data to determine the current system operations and deficiencies. And we already talked about this list, this bullet point list here of data that's available for assessments. But in this section, we're going to dive into a little more detail about kind of the theory of where and when to apply those assessments. And the basic principle is this hierarchy, and the basic notion is to work from the bottom up. If you're doing an air handling system or a chiller or a boiler, the responsibility is to assess the existing system from the bottom up in this pyramid. And if we have a building where there's 5 zones that have cold calls, and those zones can never get warm, the last thing we want to do is install new boilers and new pumps and new air handlers and then still have those same 5 zones that have cold calls and can never be warm. That would be a terrible outcome for everybody, but we've done that. And in fact, we've done that quite a lot. So when we're designing a boiler system or a chiller or an air handler system, we always need to start at the bottom. We always need to start in the zones. Where are those hot calls? Where are those cold calls? What's causing them? Are there valve problems or sensor problems or airflow problems or coil problems? And similarly, where is the energy going? Are the zones turning off at night? Are we overcooling and reheating? Are we hunting? So always start at the bottom. Check the zones first. Find the deficiencies in the zone. Correct those as part of the work. Otherwise, we can often wind up in that scenario where those 5 zones that were haunting us prior to the project will still be haunting us at the end of the project. This hierarchy also works for energy measures. If our chiller is running 24/7, that's probably because the air handlers are running 24/7, which is probably based on 24/7 calls for cooling from the zones. So again, start in the zones, make sure they're turning down so that the air handler can turn down and then the chiller can turn down correspondingly. We could talk about this the other way. If we don't assess the systems in buildings from the bottom up in this pyramid, then what we're really doing is taking on a big list of assumptions. So we would be assuming that all of the zone calculations are correct. We would be assuming that whoever drew the plans 15 or 20 years ago, that all their work was right. The zones have the right amount of heating and cooling. We assume that the turn down settings are already correct. We assume correct operations. We assume the air handlers were sized correctly. We assume the heating coils, etc. That all of that is sized well and functioning well. So when we look at it this way, it's really a tremendous lot of assumption. And in 9 out of 10 cases, at least some of those assumptions are false. So from the perspective of the portfolio, there's a whole lot more liability and risk in not doing those assessments from the zone up. So for a cute summary slide, what we're going to do here is we're either going to assume that everything outside of our scope is working, or we're going to assess and find out what's working and what's not working. And our emphasis is obviously on the latter one. So our design program requires that the engineer of record gather and analyze data to determine the current system operations and the deficiencies. In this section, we talked about this concept of the hierarchy of assessments. And as we close this section, I'll remind you again to put any questions you have about that hierarchy into our chat window.
Is this intent that all future retrofit projects, including energy engineering services, data analytics, and retro commissioning services from the mechanical consultant? Some firms have different individuals that specialize in these tasks.
So yes, I guess I'm trying to devise the question there. This is kind of going to be our design program playbook. So throughout this, I've told what our design program requirements are, and that'll be so within the design phase. These requirements are there, and so I think where the questioner was going was that there are, some firms have energy modeling specialists. Some firms use generalists to perform energy modeling. Some firms have commissioning folks on staff that can go out and do some field assessments and look at BAS data during design. Some firms don't have that, and so those are absolutely the questions that we're frankly talking to people about during interviews. We want to look at the capabilities and the resources that the firms have to get engaged in that type of work or in this type of work. And so, and that's shaking out differently within the marketplace right now. There's some firms that are, we know design firms that have data analytics departments, right, where they have people that are doing Python data analytics, as an internal design department within the firm, the same way you would have CAD in the old days or something like that. And so I can't really answer what an ideal, well, I can, you can call me personally and we can talk about firm composition. I'll tell you what I've seen in the marketplace and where I have some opinions about where I think that are going, but I won't state them here.
Is this playbook intended to apply to tenant improvement or remodel projects where HVAC is a secondary consideration of the project scope?
Yeah, that's a good question. Yes, but so yes, it does apply to TIs. However, it's a very simple. It's really very simple. So if you're doing a TI project, we do have acceptance criteria for tenant improvement projects. When you do the tenant improvement project, you want your zones to be in control. You want your, we have some of these checksums that go into place. So yes, these criteria do apply to tenant improvement projects and even small projects that fall below our threshold of checking, but they can be very quickly. There's some very quick and dirty ways to apply those. In fact, for TIs, we actually have the commissioning scope boiled down, and it's really just, you're going to check the lighting, you're going to check the zones. There's a couple pretty simple things that you can get done by your design engineer. And so it's yes, but we don't think that's a huge burden.
What are some good resources to get familiar with how to these different types of data analysis?
That's a great question. We've actually, in my team, what we did, and I've talked to some consulting engineers that have talked about this too. In my team, one of our engineers found a set of YouTube videos that just went through some examples on how to do it in Microsoft. In Microsoft, there's two tools within Excel, and then also another tool called Power BI. There's this Power Query Editor, which is a very powerful data analytics tool. And so I think every member of our team did this, literally just like a 2 or 3 hour training off of YouTube, which is amazingly eye-opening. If you haven't learned about Power BI, or Power Query, then I would highly recommend. That'll change your life today. You could do that training starting now, and by 5 p.m. you'll have a different perspective on the world. There are some other tools out there that some of our consultants are getting into using, Python scripts and some other data analytics tools. That actually varies from firm to firm, what tools we see them solidifying on and standardizing on, and like anything else in consulting, there's going to be preferences around that software. Yeah.
What would be a good way to verify existing zone level issues?
Existing zone level issues. I'm not sure I understand that. I think what we've been doing is the first thing to do, just to sort of summarize the playbook, is to look at any diagnostics that you have. If you're connected to a diagnostic systems and you know which zones are alarming cold or alarming hot, that's a great first indicator. Or you can look at the list of alarms that's showing up on our building operator's screen every morning, look at a month's worth of that and see which zones are warm, which zones are hot. Then we would get into the assessments of basically the overcooling assessment, the undercooling assessment, and the 4 a.m., 4 p.m. Type of assessment. The most common thing that we run into is overcooling and reheat. The way that you see that is that you see a CFM delivered to the zone, and you see a heating valve that's sort of constantly open, or the average valve position above 30% indicates that you're probably overcooling that zone and reheating it. On the other side of the coin, you could have a zone that's failing to meet temperature a certain fraction of the time, and it's always at maximum condition. That's the undercooling condition.
Where can we get the historical data from eBuilder?
Where can we get historical data from eBuilder? Well, okay, so I'm hearing that question two ways. So the first one is, if you're talking about the historical load data, then we've got that published out on a public video. It's actually a YouTube video that's going to be part of this California decarbonization project, and so that'll be public and widely available for historical loads. I think, though, that this question may refer to, hey, I'm just starting a project in a building. How am I going to get a hold of that utility data or the interval data on the utilities or the data that's coming from the building automation system on that building, a year's worth of data? And so that's going to come from my team. And what we're starting to do is, as we get into the OPR phase, we know that a project is coming at a building. The project manager is writing an OPR, and so we'll go and pull down that utility data, request that interval data, and just drop that data up into the folder of eBuilder, so that by the time you come along to do your design, it's sort of sitting there waiting for you. Ideally, that's sort of how it would happen. If it's not, then you would simply ask. I have an engineer assigned to every project. And so we'd always be able to dig in, and it's pretty quick. We can assemble data pretty quickly for these projects.
What type of calculations are required for AHU direct replacement projects when the rooms below are not rebalanced? This is for a packaged unit where the condenser is attached to the unit.
So what we would be looking at is we'd look at. We'd want to look at the history of the building, particularly utilities, whether it's a heat pump or a cooling unit. We'd want to look at the utility information to find out how that building is doing relative to weather, find out whether or not we do have a weather correlation or not have a weather correlation. If we don't have a weather correlation, that's something that we're going to want to change within the project. And so we'll need to find the origin of that. And then again, you would want to, even if you're doing just a 10-ton rooftop package unit, you'd want to do a contemporary design calculation for that space. The contemporary design calculation for that space may tell you that you need 15 tons for that 10-ton package unit, or it may tell you that you need 5. But we would not accept that the previous engineer from 25 years ago got it right when he picked the 10-ton rooftop package unit.
What's the expected value from energy modeling a building when we are only replacing the AC and not improving the building envelope?
So there's two parts to that: energy modeling and load calculations. One thing that we're asking for in our design program now is a set of contemporary design calculations for the building. In other words, take a look at the building and imagine that it doesn't have an HVAC system, and do a set of load calculations room by room for that, as though it was a new building and didn't have an HVAC system. And that set of calculations is what we would need to do to validate the zone by zone basis, right? You may have zone number 4 over here, and just by doing a contemporary set of calculations, you find that that zone is underserved, and so we may need more air in there, we may need less in there, air in there, ventilation, etc. So that's what we see as that value of the contemporary set of calculations, to take the existing state, whoever designed this 20 years ago, and check it against how we would design the building today, and find out where those variances are. In terms of energy models, I'm not personally of the opinion that energy models provide a tremendous value. So building an energy model in E plus or something like that for an existing building is dicey business. First off, you have to calibrate it. And we've seen calibration can be inaccurate. And so that's tricky. And then any of the scenarios that you play through it have some accuracy problems. So I don't think that's always the right answer. I think a lot of times just sort of checking that system at different conditions based on loads or based on what we can figure out outside of an energy model is a better strategy.
What would be the procedure if no historical data available? Do we rely on the loads calculations only?
Well, first off, what we're talking about here is the playbook for existing buildings. And if it is an existing building that Kaiser owns, there is no scenario where there's no data available. So if nothing else, we have the monthly utility data and we can get that going back 10 years. That is actually a really big deal, just to take a look at the monthly utility load data and sort of compare that. You can take that and divide by the operating hours and see whether or not your calculations are within an order of magnitude or inside of range or outside of range. So I would actually kind of reject the question. I don't think we have any scenario where there is no available data on an existing building. The fact that a building exists in this day and age means that it left a paper trail. And so we can get data on that. I don't think there are any utilities that we deal with where we can't get interval data at some form either. We can't always get natural gas interval data, but we can pretty much always, and I'm trying to think of an exception, I don't know of one, we can always get 15-minute electrical utility interval data. So if you have monthly bills, now you know where your building is using on a month-to-month basis. You can get utility data that tells you what you're doing at midnight and 4 a.m. versus 4 p.m. You can then correlate that to the weather. So if you're looking at a building and you're saying, hey, there's no data here, then, there is. You just got to go find it, get it.
Is there a proposed mechanism to obtain zone level issues in a building? Would we expect facility engineering support the design engineer to identify these issues?
Yeah, so there's three levels to that. If we have our Clockworks, our fault detection and diagnostic system installed, then we'll be able to see that live. We'll be able to see real data in the diagnostics. So the zones that are acting out will have faults associated to them, and so you'll be able to see those. And similarly, the zones that do not have faults, it is reasonable to assume that they're not acting out and they're not out of whack. If we don't have that diagnostic system involved, then the next level would be the BAS itself, and looking for alarms within the BAS, zones that are out of temperature or zones that are, over temperature. That's where we would look phase 2. And then the sort of lowest form of data, obviously, is expert opinion, but that's where you would ask for that. So an interview with the facility engineer to say, what are the zones that, what are the 5 zones in this building that are out of whack or causing you problems? They definitely know where those zones are. And if you walk into a building where they don't have any trending capabilities, for example, then that's when you might initiate trends on the zones that are indicated to gather some data to use in the assessment.